Okay, well, let's see. We're going to wrap up connections today. And got a couple of, I was looking through some videos I had the other day, so maybe I can show you a couple. There was a nice one from Simpson that kind of showed the array of their products. And one from here in Michigan, a builder up in somewhere a little further north. But first, the wood of the day. Whoops. Can you tell what it is? Come on, it's so dark. Obvious one here.
Walnut.
Right. Black walnut. There you go. And you can notice how it has the, okay, show these people up here. Beautiful wood because it has the light color on the what do you call that, sapwood, and then the core is usually dark, can be like dark like this, or maybe not quite so dark. So you can have a look at that. That, in fact, one of those pieces, I think the lighter one probably, came off of my property back when I lived in Tennessee. We had we bought a mountaintop which was beautiful, had a view of the Smokies, but we had to leave it all behind. But I brought the walnut tree with me when we put the driveway in. We had to cut a couple walnut trees down, and it's such beautiful wood. I mean, you couldn't just throw it away. So I took it to a mill and had it cut into boards, and it sat. I mean, we brought it up here to Michigan, and it must have sat in my shed for, 20 years, plus whatever it was, 10 years down there, 15 years in Tennessee, and I never used it. My son finally was looking at it, and he said, "Papa," he's a carpenter, he said, "this beautiful wood, let's make something." So he made himself a beautiful walnut bed. The whole bed is out of walnut. It was enough to make it big double bed. It is beautiful wood, and let's see what else we can tell you about it. Of course, it grows walnuts, right? But interestingly enough, not the ones we usually eat in the store. Those are English walnuts, are much meatier. The American walnut, if you've ever, I mean, you see them at the side of the road sometime. Take a hammer and try and break one sometime. They're very hard to break. First, they have the husk on them, and the husk used to be used for a dye. If you husk it with your hands, you turn your hands dark brown. It stains very readily, and it used to be used as a dye for clothing or for cloth. But once you get that husk off, then the core of it takes a sledgehammer just about to break it, and it explodes. And there's in American walnut, it's very difficult. You have to pick the nut out. It's very difficult to get out. So they're not used for that purpose here in the U.S. We always import ours from, or maybe we have some English walnuts that grow here somewhere commercially. I don't know. But the ones you see wild are like that. They have the darker heartwood and the lighter sapwood. It's straight grained, usually easily worked with tools. It's very heavy, hard, strong, and stiff. Has very good resistance to shock, and is well suited to accept natural finishes like, stain or lacquer or something. So because of its good properties, it's highly valued for furniture, architectural woodwork, decorative panels, and it's usually too expensive to use for just structural purposes. So it's more of a finer finishing wood. You could make your bed out of, I guess, something like that. Okay, let me see here. Oh, I wanted to make one little comment about this, where we ended the other day. we went through all those equations, and particularly for the bolt, there are like a dozen different equations you have to check for different modes of failure on the bolt. But in the end, you can go to, you just have to pay attention to, oops, get the right thing here. You have to pay attention to the kind of shear, and they've got, I mean, up in the corner, they'll have a picture of it. This is right out of the NDS, actually. It's in this one. Where is it? 12F. Yeah, it's in this chapter 12 of this. And sometimes they're single shear. You know, some of them are rated for single shear. Some of them are double shear. So they do separate them like that. And then, of course, by the main member and the side member, you have to pick the right sizes. So we did that, and we got a number. And you have to pick your density. This is not really the strength that they're looking at. I don't think so much as the density readings there. And then you pick a number. That number, I realized afterwards I hadn't really pointed out, that does not have the adjustment factors on it. So you still have to multiply that times the adjustment factors, right? So, which you could do, and you get a number then for the total. This is times the number of bolts, right? Times, in our case, 6 for the bolts. There were 6 on the side. Okay, so that actually, with the tables, is a very simple thing to check, and those are all the NDS tables, and that's what gave us, I guess, in the end, this. So this was the one that was from the bolts. Theirs is slightly rounded off more than mine. I don't hit their number exactly, but it was pretty close, within 2%. And this is the 6 bolts we got that got multiplied in the end. But you look at all these were coming from I think this was maybe the group tear out, I forget now. But these are the different tear outs, right? These modes are for the pattern, the bolt. Not the bolt itself, but the bolt pattern, right, that fails. So and it's a lot to check, but there are a lot of different possible modes of failure for that. So that's how that works. Okay. And then just a few more comments about do's and don'ts. Of course, the wood is very susceptible to splitting, and this is one of the main considerations in designing connections, is so you don't load it so that it splits. So, for example, and some of the things you wouldn't immediately think about, but this right here is not a good way to load that because it's going, cause, you can imagine that split right there when you load it, right? It's gonna do that. So it's better to load it from below. Let it sit on something. So this would be examples of that. Here's the split coming from something like that. It'd be you have to realize in advance and have the wood sit on the base of it like this. And here they've also got a little pad under it to protect it from the moisture in the concrete. I don't know if I told you that story of that Yosafat, the church I inspected in Detroit. I told you that, yeah. And the whole problem with that was they set the sill plate directly on the masonry, and in that case the masonry really did get wet. It was a lot of flooding, and that was ultimately rotted out that sill plate. Okay, here are a couple others. This is where you've got something hanging off of it, right? You don't want to hang it from the lower part. You've got to get it up in the compression zone. So here they've got it hung, up there somewhere, and that helps at least. What's really better, what they're talking about full wrap here, is it wraps this way, up, around, and down, right? This is the, so that the whole thing is over the top rather than hanging at all is much better. But sometimes that's a little bit difficult because you got, if that has some thickness and you're putting a plywood on it, that's going to make a bump, but anyway, if possible. And then other situations where moisture is a problem. And this you see, I don't know why people don't think of it, but you see it pretty frequently. There's a, over at Domino Farms, if you ever go over there, that big long Frank Lloyd Wright building, they have this, the roof comes down very low and it projects with glulam pieces out along the side, and this is exactly the problem they have. It looks just like that. And they came back, when they realized what was happening, they came back and they did basically this. They put copper plate over the ends of it and tried to protect it then. Would have been better if I don't think they did that originally. I think that was kind of added on when they realized it was a problem. And when you design these, you have to be a little bit careful that you have to think of the water getting out. I mean, you have to leave some holes down here or something so that if water seeps in there, from rain, because rain will blow on it from different directions. The important thing is you don't want to capture that water. It has to get out. So this was I think a column detail, and it undoubtedly captured the water, or the water got in here and couldn't get out, and then starts that rot. Let's see, here's some other being column detail. Oh, and the other thing, what this is pointing out is you have to realize the wood also moves. It shrinks, right, or expands, and that you don't want to restrict that movement. So if you put a big plate on like this, and it's got fasteners here and fasteners there, and then the wood tries to shrink, it's going to split. It'll split because it'll be held by the bolts top and bottom. The steel plate's not going to move, and the steel plate will end up splitting it, pulling it apart. So this would be one solution. You can break the plate and have you don't have to have it continuous through there. This fixes the top and this fixes the bottom. You don't have to have the connection necessarily. Let's see, here's some other do's and don'ts. This is one where it did exactly that. They've got a bolt at the top, or at the bottom, and at the top. So that's going to potentially cause a split if that wood shrinks. So that's not a good solution. This one way to avoid it is to put these slots in. It's a little bit hard to see. These are fuzzy. But you can slot the connection. I think these came from APA. I got these images. Or this one, I'm not sure if that's slot. It's just at the bottom, maybe a bottom hanger, and some provision made to let the water out at the bottom. So things like that. These were some other examples of, this is a column again with no, it should have some holes down here or something. The ones that Simpson now makes some really nice ones, but I think they're gauged like for a 4x4, but they have a hollow riser on the bottom that the wood sits up like by half an inch, and then there are holes in it so that the wood's first lifted up off of the concrete, and then it has holes in the bottom so that if water gets into it, it gets back out. So that's a good solution. They figured that out. This is one that might have been okay originally. It was protected down here, but then somebody filled it in with mortar right up against the wood. So in doing that mortar is going to transmit the moisture again to the wood. So that was probably not a good detail with that. They're saying, I think APA was saying, half-inch air gap. Okay, wow, that's quite a bit, but there's got to be some gap there for sure. There's no need to bring that. I mean, it's not strengthening anything to fill that in, but I don't know. Maybe they did it for air drafts or something, or probably just because it was convenient, easy to do, and didn't think about it. Here's another big. I think maybe we saw something like this in an earlier slide where they had the column in place and then it was fine, and then they cast a floor over it. This you'll see sometimes in renovations where they'd come through and put a new topping on or put something on and not protect if there's a wood, if it's an older structure, it might be a wood frame, and then they'll cast on top of that, and that's going to kill the wood. I mean, the moisture is going right into the wood then. These are better details, of course. Keep the slab below the column, or somehow prevent the moisture from getting on it. Or details like this that have a plate again that separate it. Slotted details also allow expansion or contraction. I mean, on these details, the slots work because it's not like steel where you torque it down to you're in steel, you can't, if you're trying to get a friction connection, you really tighten the bolts to the point that they don't move, right? But there's no way to do that with wood. You just crush the wood. So wood is usually just nominally tight. You tighten it so it doesn't fall off or it doesn't get loose again, but it's not torqued down. So if it does move through shrinkage, then having a slot there should allow it to move a little bit. Okay, this was another situation that I think was in the APA literature. Yeah, APA's literature. This is a big diaphragm type roof. I think it was some sort of a factory or something, and in an earthquake zone. And if you have lateral movement, this would primarily be from an earthquake. These heavy, the masonry walls are going to move more than the lightweight diaphragm roof. They're going to, you'll have the roof here, and the inertia from the heavy masonry is going to pull the masonry. So, the shock comes, and I guess the shock would go this way. Maybe the masonry would move, or maybe I got it backwards. Anyway, the masonry moves differently than the diaphragm. And if you've just got them held together, like say you had this plate here and just nailed that diaphragm roof to the support, it would just rip that nail off. It would just pull it apart. So you have to realize there's quite a bit of lateral force in that situation. And what they recommend are these ties, that you have these anchored back into the masonry, and then with multiple fasteners, maybe more than two. In fact, this would be something like one of those fasteners. It's almost like the connectors we saw for shear walls, right? That were doing the same thing. In a shear wall, you've got the wall's doing this, right? And you're trying to hold it down. And this is almost the same thing. This wall is pulling away, and you're trying to hold it together. So it's a very similar detail. And so you've got to have some sort of a connection like that to spread. It's probably more than just two screws. It's probably like those, half a dozen screws or more that hold that together. Okay, and talking about shear walls, these we did talk about before. Of course, when it deforms, right, the panel's going to remain mostly rectangular, and what deforms is the frame behind it. So you get the attachments then ripping apart, right? You've got the panel that remains pretty rigid, and the frame behind it is kind of moving a little bit, and it the frame is kind of doing this, and the panels then are remaining square or rectangular, and so that it puts a shear force on these edge connectors, particularly more the edge, just geometrically. You know, when something rotates, this is moving more than this, right? So the ones toward the edge are the ones that really take the load, and these are the ones that are going to rip off. This is why you look at those requirements, and the edge nailing is always more. You know, it's like 3 inches on center or something, and the interior are only 6 inches on center, or whatever, often. So that's part of it. But at the same time, that having the nails pull out and bend like that actually is a good thing. It adds a lot of ductility to the system, right? If you made it too rigid, then the wood would start to break. It's probably better to let the ductility take place in those fasteners. I mean, I guess presumably you could come back afterwards and maybe try to repair that more easily than if the panels were destroyed, right? At any rate, that's the way that works. And then of course you've got the hold downs at the corners, and then these are taking the shear at the base. I show a lot of them there. They're usually just one. They're like 2 foot or 4 foot on center. These base anchors usually, I think. And those can be of 2 types. They're the ones we looked at earlier when we were talking about the shear panels were cast, a J bolt. So it's just a bolt with a hook on the end, and it's cast in the foundation. Of course, the tricky part about that is that means the guys that are doing the slab, the concrete workers, have to place all those, and they're not the carpenters that are going to put them together. So it's like 2 different crews that do that, and you could get a little bit of a miscommunication, and you know, to have those exactly in the right place. Even that video, I thought was funny. Oh no, you didn't see it. I was showing the other class a video of a masonry construction, and it's the same thing. You cast the bars into the slab first, and then you put the masonry on it. And this guy was demonstrating it, and he came to put the block on, and the bar was, you know, not quite in the right place, and he's sitting there trying to pull the bar over. Yeah, it's hard to get them in the right place, casting them like that. So that's a consideration, because there are other options. You can drill it. I think I got a video in the end here today that shows other options to do those connections. Anyway, okay, so here we go. Yeah, this just shows the better illustration of why those, you know, these are the pieces that are carrying out, right? The fasteners at the edge, and the sill plate is taking the shear, and then the uplift at the corners. Okay, so that's how those shear panels work. Oh, yeah. So part of that, what that was illustrating, these edges then are kind of critical, and in the criteria for those, they'll usually say they have to be 3 inch. Well, 3 inch or 2 inch pieces. So here in Michigan, as far as I know, I don't remember see 3 inch pieces very. I mean, maybe you can order them, but usually they're not. And so it'd be difficult to get a 3 inch piece, but you can use two 2x4s. And then the nails should be staggered. And this was just illustrating what they mean by staggered. This can be a little bit confusing to carpenters, and you may be in the position to inspect it. I don't imagine you'd be out there driving the nails, but you might be walking through inspecting it to see how the job is being done. And this is not staggered. Even though it kind of looks staggered, they're not. They're in a the critical part is those are lining up in a straight line, and the danger is that you follow the grain, you'll split it. Grain you can put them as close as you want this way. The grain's not going to split in that direction. But if they line up in this direction, that's a problem. So lining up in this direction is no issue. It's this direction that you've got to watch. So this doesn't matter. You can make them, that's okay to have them lined up that way. But here there is what the stagger's about. And it's not a lot of stagger, but at least it hits different grain. So that makes it does make a difference with the wood. Trying to avoid that splitting. Okay, and then let's see what else. This just shows, here's the double 2x4. This almost looks upside down, but I guess this is a plate at the top. They'll use those big square plates also on the shear plates at the bottom sometimes to hold it in place. It distributes the load a little bit better than a simple little washer. Here's an example of those nails pulling out, right? And they failed. They pulled out. At least they didn't. Oh, yeah, I guess they did pull through too. This one didn't. That one's still there. But that, although it failed, it had a good bit of ductility in that failure. So that's kind of what you want, is that ductility. Okay, and then this just gives the details, I guess, from the NDS. This should be the NDS criteria. No, I take that back. That's not NDS. This must be more of APA's, I think. I got these out of APA's literature. 2-inch spacing, 10 penny nails. So they're pretty explicit on the details of those. And you can remember when we looked at shear walls, they had the spacing and everything in some of those tables that they go through. They also talk about joining edges. So there's an edge and there's an edge. And if the edges, and this is a little bit difficult to stipulate in your drawings. I don't see how you'd really manage that, but it's something that you could give as a written specification and then try to pay attention and see. It's difficult to see though because it's on opposite sides of the wall, and by the time you get out to the site to see it, it's covered. You can't see what's behind it. But if you have staggered joints, then you can just do them on a 2x4. If they line up, then you're supposed to use the 3-inch framing or 2 times a 2x4, right? Okay, this thing, I gotta get a new pen, I guess. This thing's about illegible. Okay, so that's another detail. Now, there was a, see if I got this video here. This is a guy, actually here in Michigan. I looked at his place up on the map. I think he's right about up here. We're down here. He's right in there. But does a lot of home construction, and he's had a little discussion on walls, detailing walls with 2x6s or 2x4s, which I thought was kind of interesting because I've always looked at it in terms of strength, and usually you don't need it for strength. A 2x4, unless you've got an awfully heavy load on it, you usually don't need a 2x6 wall. You can adjust them, the spacing, right? If you got them 2x4s 12 inches on center, that's a pretty strong wall that you wouldn't need to go to a 2x6. But and of course the 2x6 gives you a larger plenum in there, right? You got a little bit of space, which for plumbing would be useful. What I hadn't even really thought about, but what this guy was pointing out, is people do it in higher priced homes. So they'll do it to put more insulation in there. You have a thicker panel to have more insulation, and his argument is that's not a very good way to do the insulation. So I thought that was worth, let me see. See if I can make this play. I think I finally figured out that to make things play, I've got to have a pointer. Did it work?
Well, 2x6 versus 2x4, it's a little bit of a trade-off. I personally try not to build with 2x6. We certainly will do it if any customer wants it, but the reason I like 2x4 is I can get a finger joint stud, which is a stud
this
that's
was
been
interesting.
cut about every 2 foot, and then finger joint glued back together. So it's
He prefers
extremely
those.
straightforward.
I was kind of surprised.
I cannot get that in a 2x6. I'm just getting a regular stud, and if you've ever gone through a bunk of studs, you'll see you got to throw out probably 30 or 40 out of each bunk. And my worry is one of those gets in the wall. And then we've got a problem. You know, if it's in your kitchen, your countertops and your cabinets don't want to sit right. And so
'Cause
I've
it's
typically
warped.
stayed with a 2x4. The value of going to a 2x6, I know, is you've got a bigger wall cavity, so you can get more insulation in there. But what typically happens with that, when you put that insulation inside your house, they're not putting it on the outside like we do. So we typically put an inch of styrofoam on the outside of our house. And the reason I like that, it performs as a thermal break. So you don't have the heat coming from drywall to your stud to your OSB on the outside and going right out of your house. And if you've ever driven around on a frosty morning, you can tell who doesn't have a thermal break because you can see every stud in their siding because it's collecting that heat. So that's another reason when you see people build with 2x6, they typically just put a house wrap on the outside because they've got their R value already inside their wall and they don't want to spend the extra money on the styrofoam. But that thermal break, I think it's really important energy-wise. You're not soaking energy right out of your house.
Well, there you go. And the other comment he made about the finger jointed lumber, I had never really considered that, but apparently that's more stable in terms of warping or deforming. It's very true. I mean, I've gone down to Lowe's trying to buy 2x4s. You pick them up in the pile and you're kind of going through them and they're not straight. You know, it's hard you have to sort through them to get a straight one. And the problem is you put them up in a wall, and then if they're too bad, you've got a bump in the wall. And you'll either notice that, or like he was saying, in a situation where you're putting cabinetry around, it can actually be a problem. And then you've got to come back and try to fix that. I think the other video I have a little later shows ways to fix that, but it's kind of a nuisance for sure. I mean, it costs you then labor to fix it. Okay, these are some more. Oh, this is out of the IRC and the IBC, the International Building Codes. Their details, they have also stipulations if you look in there, and usually they just reference the NDS or have the same, they're at least in agreement with them. They had a few details that I noticed that were specifically on joinery, and here they're specifying. Oops, okay, sorry. Get back to my pen. They specify the nail size. There's a table that's giving those nail sizes. They also equivalent screws if you want to use screws, and they pretty much agree. This was a comparison between the residential code and the International Building Code, and they'll stipulate how those are actually used. So this is just on a floor. This is rim board, of course, and screwed or nailed into the end of that. These are beams, joining beams, not a flitched beam, just a regular beam, screwing them together. This should be the same pretty much. Remember, we looked at that with columns and that nail spacing, and you're supposed to have it, according to the NDS, these are supposed to go all the way through. Here they're in the IBC, they're showing them, they just going through 2, right? It doesn't look like it's going all the way through to me. I have to read their details on that. Maybe for a beam it's not as critical, I guess, as a these are beams, not columns. For the columns, maybe it's more critical. Although, like I said, in construction, I don't think people really do that too often. Get long enough screws. These are details on joining of the top plates. You know, normally we have a double top plate on a stud wall, right? And this would be how to do maybe the lap splice, the sill plate are toe-nailed in, and the top plate on that. Okay, so that, and again, it's just giving you the size of these. Most of them 16 or 10. 16 is pretty big. I guess the ones that are being toe-nailed are usually 16 penny because they gotta go through a further distance. Details on their rafter construction and that kind of stuff. So it's similar, and I guess the most interesting part of these tables to me is seeing what they stipulate is the size of the connectors. Okay, I think there's one more. Yeah, these are just details on roofs. Okay, and then this was the other video I thought I'd show you. This is from Simpson. Let's see if we get where my pointer arrow. This goes through and shows a series of their connectors and, you know, examples, I guess, of in-use applications. So it's...
Hello and welcome. Simpson Strong-Tie leads the industry in product innovation, quality, and technical support for structural connectors. In this short video, we'll cover the basics for correctly installing Simpson Strong-Tie connectors. Effectively utilizing these connectors not only makes construction more efficient, it creates a stronger, safer, well-connected structure. First, making a good connection requires having the right connector. The right connector should be chosen by your architect, engineer, or designer. Our job is to be sure that it is installed correctly. Once the correct connector has been determined, the single most important factor in correct connector installation is the proper use of fasteners. So let's take a look at some of the fastener types that we're using with Simpson Strong-Tie connectors. Depending on the kind of connector chosen, you may use nails, machine bolts, strong drive screws, or Titan masonry screws. But it's more than just the type of fastener that's important for proper connector installation. So let's look at the most common fastener used with Simpson Strong-Tie connectors, the nail.
There are many different types of nails, so make sure you're using the correct one. Fortunately, most Simpson connectors have the required nail stamped right on the product. But if you're unsure, simply refer to the current Simpson connector catalog. Although two nails may look alike, there are three key features of a nail that will affect the performance of a connector: diameter, length, and finish. The diameter of the nail shank, often referred to as the gauge of the nail, affects the shear capacity of the nail. The thicker the nail, the more shear resistance provided, so be careful. Substituting a nail with a smaller diameter shank will reduce the load capacity of the connection. Here are some common nail types with their associated diameter and wire gauge. The length of the nail is the next most important factor in determining the connector capacity. The reason is simple. Nails must have enough penetration into wood to achieve full shear capacity. Here are some common nail types with their associated lengths. Some connectors require full-length nails and cannot use shorter versions. Examples include hangers with double shear nailing and some heavy top flange hangers like the HGLTV. For other products, substituting a shorter nail will result in drastic load reductions. Never use short nails without first verifying whether they will work. Here are some common nail types with their associated minimum penetration lengths. And keep in mind, when using our patented double shear nail hangers, you must use the specified full-length nails. And finally, consider the finish of the nail. Galvanized or stainless steel nails may be required for corrosion resistance. Check with your local building department for specific code requirements. It's important to realize
This is
that
a
many of the
slippage.
nails found in lumber yards are not appropriate for use in connectors. Examples of these nails include drywall or sheetrock nails, roofing nails, and small common nails like the six-penny nail. These nails lack either the length, thickness, steel composition, or coating needed, and they substantially reduce the load capacity of your connectors.
Remember, the incorrect use of fasteners is the single most common mistake made during connector installation. Now that we're aware of the importance of using the right nail for each connector, let's spend some time talking about installing those nails. Metal claw hammer, still the tool of choice.
But palm nailers can also be used, and are a great way of reducing installation time when used with the correct bag nails. Some pneumatic nailers can also be used, provided they have nail hole locating mechanism and they use the correct nail for the connection. Do not overdrive the nails. The nail head should be seated flush with the steel. Keep in mind, though, that most standard framing nailers cannot locate holes and therefore should not be used to install nails into connectors. And furthermore, since most collated nails for standard framing nailers are undersized, they should not be used to install connectors.
Now let's talk about screws. Since screws act differently than nails, they cannot be interchanged.
Screws are often tempered, which makes them brittle, and therefore will not yield the shear strength that nails provide. Examples of common screws not suitable for connectors include drywall screws, deck screws, and lag screws. But Simpson makes a patented screw called the SDS, or strong drive screw, that is code listed, needs no pre-drilling, and comes with the connectors that require them. But beware, do not mistake an SDS screw for a lag screw. A lag screw will not achieve the same loads as an SDS screw and is not allowed with Simpson strong tie connectors. And finally, for those connectors designed for use with masonry screws, remember to pre-drill those holes, the required diameter and depth for correct installation. The drill bit diameter can be found on the packet of screws, and it must be drilled at least 1/2 inch deeper than the screw length.
Now let's talk about machine bolts.
They should of course be pre-drilled to a diameter only 1/16 of an inch larger than the bolt itself, and they require a washer on the wood side of the connection. Carriage bolts, lag screws, and all thread rods cannot be used in place of machine bolts. It's important to remember, a pre-drilled hole that's too big for the bolt will compromise the integrity of the wood and make for a weak connection. Since repairs for poorly drilled holes can be costly, make sure the drill bit is of the right diameter, it's not bent, and you drill the hole from one side. Don't try to meet the hole in the middle by drilling from both sides.
You probably noticed that Simpson Strong Tie has different shaped holes throughout its product line. You'll see round, oblong, triangular, diamond, and hexagonal shaped holes in our connectors. But what do these different hole shapes mean? Well, each different shape indicates a different fastening requirement.
The most common shape is the round hole. This hole must be filled with the fastener type specified. The only time you may not fill a round hole are for straps and strap type hangers. These products have more holes than are required to allow for multiple fastening capabilities. Oval or oblong holes are simply used to provide easier access in tight locations and should be treated like round holes. As a general rule, all round and oblong holes should be filled with the appropriate nail. Triangle holes are used for increased capacity and must be used if specified by the designer. Connectors that have triangle-shaped holes have a minimum and maximum load value. To achieve the minimum load value, you must fill all round holes. To achieve the maximum load, you must fill all round and all triangular holes. Diamond-shaped holes indicate a temporary fastening option and are there to aid installation. It is not required to fill diamond-shaped holes. Hexagon-shaped holes are used exclusively in conjunction with our Titan masonry screws, and these holes must be pre-drilled.
Along with different hole shapes, Strong Tie connectors use a variety of innovative design features to help secure their connectors with greater efficiency and more precision. The most common of these are the patented tabs and domes.
Both of these features force the nail at a 45-degree angle, providing correct installation of our double shear nail design and allowing for a much simpler, faster, and stronger hanger installation. Simpson also uses this 45-degree feature with engineered wood product connectors, commonly known as I-joist hangers. This application is referred to as PAN, or positive angle nailing, which actually forces the nail into the wood at a 45-degree angle, minimizing wood splitting problems. Other I-joist hangers feature a bend tab that locks the hanger to the bottom chord of an I-joist, which prevents joist movement and therefore minimizes squeaks in the floor system. Simpson's newest design, the IUS, features a snap-in seat requiring no joist nailing for the fastest possible installation and huge labor savings. Speed prongs are another strong tie innovation found on many of our connectors. Since it can be difficult to hold a connector, hammer, and nail all at the same time, these handy prongs are used to temporarily position and secure the connector for faster, easier installation.
Now that the connectors are installed, it's a good idea to check your work. First, verify that all the appropriate holes have been filled with the specified fasteners.
If this has not been done properly, it could result in a premature failure of the connection, which may create a life-threatening condition. Once you have determined all required holes have been filled, check both parts of the connection to ensure fasteners are installed into appropriate material, like lumber or masonry, and not into thin air.
Yeah.
So let's take a moment to recap what we've learned. First, we know how important it is to verify that we have the right connector for our construction plans. Second, we learned how important it is to use the proper fastener for those connectors. We learned that nails must be the correct length and diameter. And don't forget to check local agencies for any special corrosion considerations.
For screws, we know that Simpson Strong Tie offers two types of code-listed structurally rated screws, the SDS screw and the Titan masonry screw. The SDS is code-listed as a self-drilling screw, but remember, a lag screw is not an acceptable substitution for an SDS. And because of the base material, it is necessary to pre-drill for proper installation of the Titan masonry screw. We also learned that machine bolts must be pre-drilled to a certain tolerance, and that a carriage bolt or all-thread rod may not be substituted for a machine bolt. In addition to the proper fastener, we know how important it is to use the correct quantity of fasteners. We learned the significance of all the different hole shapes and design features, each representing a different requirement or feature. We learned about innovative features like tabs, domes, pan nailing, and speed prongs, all designed to aid in proper installation. And finally, Simpson Strong Tie connectors can only be as good as the base material to which they are fastened. Make sure that the material is suitable for fastening and will support the load developed by the connector.
After all, Titans, SDSs, and nails can't work if they're not fastened into adequate material. If you're not sure or it's not stamped directly on the connector, remember, all fastener types and quantities can be found in the current Simpson Strong Tie catalog or on the web at www.strongtie.com.
Okay, there's strong ties. Yeah, it is interesting there. I mean, in terms of inspecting, it makes it very easy to inspect that you can see which holes are not filled. And the one comment they had there, I don't know if you caught it, where they nailed, well, of course on the truss where it was not attached, I mean the nails went in, didn't hit the wood, right? They missed the wood. Of course, that's not too good. But the other one was on the insulation, trying to nail through insulation into the wood. Well, that's going to leave that much of the nail not supported, right? So that's not a good solution either. So, I thought that was an interesting video. A few good do's and don'ts. And oh gosh, we're going to finish early today. I wasn't sure we'd get to this. This is one other video that I thought was good because he goes through also talking about not just the fasteners, but the mentions how to solve some of the details where the wood walls are not straight. You know, that other builder was commenting that he used the finger jointed lumber to get straight pieces. And this, they talk about that too here, and how you actually, what you'd have to do if they're not straight. Anyway, this is that guy we saw one of his videos earlier on the Reisinger homes. Did the video on the different, what was it, plywood versus OSB, I think. Okay, so see if I can get this to play.
The Build Show today, talking about engineering. We're at my house under construction, and I did a couple things here and used a couple very special products that made my house especially strong, but also made it a little easier on me and the framers for construction. Now, we're going to be talking about new construction and remodeling, some tips and products that I think will help you on your next build. Today's video all about engineering. Let's get going.
Okay.
All right, guys, I got my friend Whit Smith here, the engineer who has worked with me on a bunch of projects in my personal house too, Whit. Whit, let's talk about some of the modern hardware available and some of the things we did on this house to make sure, number one, my house was structural, but also to make some of the construction easier. So first off, Whit, talk to me about those metal ties that are going from the top plate to the rafters.
Well, these are hurricane ties, and that's how we attach the rafter to the top plate of the wall.
Yep.
And that's not something that's all that new. We've been using those a long time.
Yeah, it's been a couple decades.
That's right. I think most of our framers are going to be very familiar with that. And what we're trying to achieve by attaching the rafter to the top plate is a continuous load path to resist wind uplift.
Yeah, so as the wind's trying to grab that overhang, it's holding that roof down to this wall, right?
That's correct.
Yeah.
And then to maintain that load path, we have to attach the top plate. Eventually, we want it connected to the foundation. So we're going to attach the top plate to the studs using our continuous sheathing. So as an engineer, we love continuous sheathing because we have shear strength and we have resistance to uplift throughout the entire home.
So shear strength meaning that racking, like when the wind hits one side of the house, it's resisting this kind of movement, right?
Exactly.
But then this is also helping us with uplift too, is that right?
That's correct. So our sheathing is going to now be attached to our double bottom plate. In this case, it's a double plate due to our floor detail. And then we have to attach the bottom plate to the foundation.
Okay, so this is a remodel house with. This was originally a 70s slab, and we've got some new framing on it. When we took the house apart, I realized the bottom plates were power actuated. Basically a nail that's shot down through the concrete. But a nail, in effect, that wouldn't give you enough value to hold the house down. Is that right?
That's correct. And in fact, that doesn't meet code. That's how we would attach an interior wall, but an exterior wall requires half-inch diameter J-bolts most commonly. In new construction, you're going to see a half-inch diameter J-bolt, or you're going to see, there's a new line of products out that they call mud seal anchors. And that's similar to a joist hanger. It's a light gauge metal hanger that you can attach to your concrete form. So you install them before you pour the concrete, wreck your forms, and then you lay your plate down and you attach it using that mud seal anchor.
Kind of folds over.
Exactly.
Okay, I've seen those.
Now that wouldn't have worked in our application here because our foundation was existing, so we had to post-install our anchor bolts. Fortunately, Simpson has a whole product line now. Well, I wouldn't say a whole product line, but they have options for post-installed application in a 2x4 wall.
And what's that product called with?
This is a Titan HD. It's a heavy-duty screw anchor. And the challenge in attaching a 2x4 wall to the foundation is we're only 1 3/4 inches off the edge of the foundation, so not all hardware is going to work in this situation. So this is one that specifically is approved to install a 2x4 plate to our foundation on the edge of the foundation.
And some of our options might have been, let's say, wedge anchors or epoxy set anchors, right?
Epoxy for sure. I know that's an approved solution. I'm not sure about wedge anchors because a wedge anchor, the way it is installed is when you tighten it, it actually exerts an outward force on the foundation. So that might be one that doesn't
So if we're
work.
that close to the foundation, that probably wouldn't work because we might want to bust out the concrete with that pressure against the sidewall, right?
That's correct.
That makes
correct.
sense.
Now what else I like about this is it does not require a washer necessarily. It has a built-in washer. Most J-bolts are going to require a washer when you install it. And I can see here we installed a washer, which I would consider to be an upgrade.
Yep.
This is not something we see in all of our
So
homes
this
now.
big fat piece of metal right there with a slot, by the way, to make it easier, wasn't necessarily required in my zone because I'm not in a particular hurricane or seismic zone, right?
That's correct. Now in a high seismic or a high wind zone, you are required to use these larger washers.
Okay, gotcha. All right, Whit, so on those Titan HDs, talk to me about spacing on those, whether you're using those or any other anchor.
Yeah, the spacing is going to be the same for these, whether they're cast in place or post installed, and the code requires a 1/2 inch diameter anchor, spaced 6 feet on center. Now, I would say the industry standard is to go ahead and space them all 4 feet on center. That allows a little wiggle room, a little room for error, and not too much additional cost throughout the course of a project.
That makes sense.
The other thing to know is we have to install an anchor within 12 inches of a corner, but with these, it's not closer than 6 inches. And with a regular J-bolt, you should be not closer than 7 bolt diameters.
Okay.
So a good rule of thumb is 6 to 8 inches from a corner.
I gotta say, these Whit, when the guys came to install them for me, were really easy to use. All we did was we post drilled them. In fact, you can see a little bit of the kind of dust from where we drilled them. There's still a little bit of concrete dust on the floor right there. And with our Milwaukee drills, we just use all battery operated. They were super easy. Drilled them. And I probably did the entire, now the first floor in this house is about, I don't know, 1,600 square feet. We easily did it with 2 guys in a day, including the garage space as well.
That's
So
great.
pretty straightforward. The other benefit of these over J-bolts in my mind is we actually did pour one new section of concrete, and all my J-bolts were right where my doors were. So we had to come back and saw them off. So by placing these after the fact, even though this was kind of a hybrid, mostly remodel with a little bit of new, was sure nice to just go back and go, all right, where do we need them? What's the engineering on this, or what's the code on this, and boom, drill them and anchor them. Rather than having the concrete guy think about where's the framing, where's a window, where's a door, that sort of thing.
What else I like about these is they're removable. So if you install one in an incorrect location, you can always back them out just like you would a screw
That is pretty nice.
and relocate them.
And talk to me about length real quick, Whit. Do they need to be this long?
Code requirement for a J-bolt is 7 inches into the foundation. Now the Titan HD 1-for-1 replacement, you only need to extend 4 1/4 inches into the foundation.
Oh, wow.
So typically with a single bottom plate, you could use a 6-inch anchor. In the case of your home here, where we have a double bottom plate, we had to use the 8-inch long anchors to satisfy the code criteria.
Because I got 3 inches of wood to go through before I even get to the concrete.
That's correct.
Yeah, got it. Good stuff. Wait, let's go talk about some hangers that we use that are kind of specialty hangers. I'll meet you over in the living room. All right, Will, let's talk hangers. Now, everyone's familiar with a traditional, deck hanger. We use some hangers here, though, that are pretty serious and something I'd never seen before. Will you talk to me about these we used here?
Yeah, this is something I'm only becoming familiar with. It's still relatively new on the market, but I've been really impressed with it. This is a slopable, skewable face mount hanger.
Damn.
So where we would normally have to come in and cut a seat for the face mount hanger for the rafter to sit in the face mount hanger, we don't have to do that here, so it allows us to keep that ceiling plane flush all the way out to the edge of the beam.
Yep.
And still get our the loads support from our face mount hanger.
There's a lot of load on there. Isn't that a double 24-inch tall LVL beam up there?
It is. It's spanning a long ways, has quite a bit of load on it. It's supporting our light well up over the stair,
Yep.
plus all this roof here in the living room. And we're always very conscientious about limiting deflection. So the best way to do that is with deeper framing members. So here we have a 24-inch LVL beam supporting this room.
Now, we used LVLs here in this framing, but could I have used 2x10, 2x12, something like a traditional solid sawn lumber in here as well?
We could have, and that's a common use of solid sawn lumber. However, if we use LVLs, we have a flatter ceiling. We can have reduced member depth to keep that ceiling profile not as thick. And they're stronger. LVLs are stronger than solid sawn wood.
Yeah, and then ultimately probably a little less deflection too, right? Especially when we get a fairly long rafter like these going.
Exactly. And that's going to be very noticeable when you walk up the stairs and turn around and sight down that ceiling. Any deflection at all, you would see it.
Yeah, you're going to see that. And I'm doing all level 5 smooth here too, so I don't have a lot of texture or other things to hide those sins with shadow lines. And then we also use 2x4 LVL studs on this house. I'm sure someone watching this has never seen those before. That was a spec for me where I said, hey, I want to use this. I hadn't built a whole, well, I've done one house before with them, but I was really wanting to try them for flatness and straightness. What do you think about them after you've seen them here and looked at the engineering on them?
Well, we're always a big fan of engineered lumber. It's more dimensionally stable, it's stronger. In this case, you have a wider nailing surface. They're wider than a 2x4 stud, and they always have more structural strength than solid sawn wood.
Yeah, and I love that there was no call. I mean, every single stud we took out of the pile we used, there was nothing left over, nothing to send back to the lumberyard that had some bow or wane or issues that caused us to cull it out of the sack. Wait, let's go upstairs and finish up the video talking about some screws that we used. All right, Whit, let's finish off the video up here where we used a version of this screw. This is kind of a, for lack of a better term, a timber lock. That's actually a different manufacturer than Simpson. But as far as I know, they were the first in the category, and a bunch of different people, Simpson, Spax, Fasten Master, make some of these. What are these kind of originally intended for?
Well, they have a lot of different uses, but at the end of the day, they're meant to replace a lag screw. So this, you don't have to pre-drill. Most of the manufacturers advertise this diameter screw, it's close to a 1/4 inch diameter, as being able to replace a 3/8 inch diameter lag screw.
Oh, that's nice.
So we can install this screw, no pre-drilling, and get high load values. It has many uses. It can be used to attach ledgers. It can be used to attach multiple plies of engineered wood, such
It's
as
kind of funny as
LVLs.
you're talking, I'm hearing the guys using one outside right now.
Yeah, so you can hear how they're installed. Impact driver, they go right in.
Yeah.
High load values. I recall earlier in the year we were using them to attach our ceiling joists together when we were building what we were considering to be a 3-piece truss.
Yep.
And we had to connect the bottom collar ties, the bottom ties together.
Yeah, so basically these LVLs that are kind of next to each other, we're stitching them together with that lag.
That's
right?
correct.
And that's kind of making this truss design that we made into my ceiling here. The beauty of these, I think, as from a builder's perspective, is that no pre-drilling, no having to make a pilot hole for these. That's huge. For production, all we do is grab a impact gun and just drive those things in. So
Agreed.
much easier.
I'm also a fan of the large head on them also.
Yeah, because you're really catching the wood and you're forcing that together. You're not worried about, oh, did they put a washer on that screw, right?
Exactly. In my opinion, continuous plywood or OSB sheathing should be standard practice on all homes.
I totally agree. I mean, so much better from both a structural perspective, but also when it comes to water and air holdout and being able to have something to either apply a sheet applied product, a fluid applied product, or a tape product. So now I've got a really efficient house and a really airtight house. Totally different. Whit, really appreciate it, man. My house, this is my current house under construction. Whit's actually here working today, checking out my final inspection for framing. We're making sure that everything was done to Whit's standards and met the engineering that he designed for my house. Any last words about the construction we did here? Anything that is interesting?
No, it's a beautiful house, excellent framing job. It's been a pleasure to be a part of it.
Man, I really appreciate it, Whit. Guys, I really appreciate you joining me for some of these common, for us, but not always common, engineering solutions and hardware. Hopefully you learned something. Big thanks to our friends at Simpson. They've been a great supporter of both my work and a bunch of engineers like Whit's office over the years.
Okay. All right. Well, that gives you kind of, I thought it was kind of interesting to look at the details that they talked about. So, you know, where the guy here in the Great Lakes was using the finger jointed to get straight lumber, he was using LVL. I think the LVL is considerably more expensive, but it has the advantage that, I don't know if he really brought it out, but if you looked in that living room space, there was very high ceiling, and you can get the LVL, I think they were going full height, so you can get that LVL to go, 20, 30 feet. It's the only thing that limits it is the transportation of it. So that's an advantage, is to be able to have it continuous. It's like the old balloon framing that we used to do. It used to be the studs would go from the foundation up 2 stories. They'd be full all the way to the roof. But we don't, we break them now at each level. Okay, well, I think that's finished up a little bit early on that one for a change, huh? Is everything going well with your projects? I think you guys have got it pretty much together. I updated it on the website as far as the due dates and the dates of the presentation. I don't know if I can show you that here. Maybe, but you can look at it. Yeah, there we go. This is on our website, on that project page. This will be the, whoops, this is what you signed up for. Whoa. Signed up for. So that's going to be the rundown. That's next week, right? Is that next week? Tuesday the 12th, I think, is when we start that. And that'll be the last 3 days of class then. And it looks like we just about got everybody scheduled. So it'll be pretty full to get those all in. Okay, and the idea is you do come. Here's for all you people that are not here. You are supposed to come and attend this. It presented in person at least, and we'll have a little evaluation form. I let you kind of evaluate them as well as I'll evaluate them in the end. But that's always kind of interesting. At least I think what's kind of fun about this is it gives you a good overview of different things. A lot of people tend to, you can see by the topics, we got a few that are on testing. We tested our Flitch beam the other day downstairs. It held up pretty well. And as well as some very interesting projects that the Eagle River Bridge, that's here in Michigan, right? Is that where that is? Up a little further north? So that'll be nice. Something we could, someday maybe you get a chance to go see it. Who knows? All right, very good. We'll see you then on Thursday. Finish up